Hello. We will continue our discussion on queuing models. This is a second video in this series. For this session, we will take up the QT&OR question paper asked under Bangalore University in the year 2018. The fifth question was on queuing models. I will read the question. A telephone repairman finds that the time spent on his job has an exponential distribution with a mean of 20 minutes. If he repairs sets in the order in which they came in, and if the arrival rate of sets follows a Poisson distribution approximately with an average rate of 10 per 8-hour day, what is the repairman's expected idle time each day? How many jobs are ahead of the average set just brought in? This is the question. As I mentioned earlier, read the questions at least 3 times so that you will understand what has been asked in the question. Here, a telephone repairman, he is there in his workplace for 8 hours in a particular day. In that 8 hours, the time taken to repair one telephone is 20 minutes. So what we read, the time spent on his job. His job is to repair telephones. So for every job, he spends 20 minutes. You can see the words exponential distribution, then Poisson distribution. These are some of the assumptions of queuing models. You can also notice one more word. If he repairs sets in the order in which they came in, that is first come, first serve basis. This is also an assumption of queuing models. We'll come back to the problem now. So first we will see what is given in the problem. First is he spends 20 minutes to repair or to service a telephone. So the service rate is given. Next, the arrival of telephone sets. The arrival of telephone sets follows a Poisson distribution approximately, then average rate of 10 per 8-hour day. This is the arrival rate for the telephones. We'll go to the given statement in the problem. So arrival of the telephone sets, which is given by the notation lambda, is equal to 10 per 8-hour day. In a given day, it is an 8-hour work for this repairman. So each day he gets 10 telephones. So what is the number of telephones that is arriving per hour? 10 by 8, which is 5 by 4. So lambda or the arrival rate is 5 by 4. Then the time spent by the telephone repairman on his job, that is time for repairing one telephone set is 20 minutes. So from this we can derive the service rate. The service rate mu is equal to 1 telephone is repaired for every 20 minutes. So how many telephones the repairman would service in 1 hour? So multiplied by 60 minutes, which is 1 by 20 into 60, will get per hour, and that is 3. The service rate mu equal to 3. The reason for converting this minutes into hour is to have both the arrival rate and the service rate at the same units. Then we are asked to find the expected idle time of the repairman and the number of telephone sets ahead of the average set just brought in. We'll see what are these two questions. The first is expected idle time of the repairman. Total work hours minus busy hours will give us the idle time of the repairman. So total work hours is 8 hours. Busy hours is given by the traffic intensity. So traffic intensity, the formula is lambda by mu. Number of hours the repairman is busy in a 8-hour day is equal to 8 into traffic intensity. Traffic intensity rho is given by lambda by mu equal to 8 into 5 by 4 by 3. Lambda is 5 by 4, mu is 3, which in turn gives us 8 into 5 by 12 equal to 40 by 12, which is 3.33 hours. So the total hours the repairman is busy in a day is 3.3 hours. In the problem, we are asked to find the idle time. So the idle time is total work hours minus busy hours in a day. Total work hours is 8 hours. Busy hours is 3.33 hours. And so the idle time is 4.67 hours in a 8-hour work day. We will move on to the next subdivision B. We are asked to find the number of telephone sets ahead of the average set just brought in. Let us assume these are the telephone sets which are already in the system. Now what we are asked to find is if a new telephone set is brought in for the servicing, how many telephone sets are ahead of the just brought in telephone set, that we need to find. So we are to find the number of telephone sets in the system. In other words, we need to find the length of the system. The length of the system is given by the formula lambda by mu minus lambda. We have the value for lambda, we have the value for mu. By substituting these two values, we can find that the average length of the system is 0.714, which is approximately one telephone set is there in the system, either in the queue or it is being serviced. So when a telephone set just arrives, it needs to wait for the one set which is already in the system to be serviced, and then the current just brought in telephone set can be repaired. So this is how we need to answer the questions on queuing models. It is a very simple problem. It is asked in a 5-mark question. Only thing is we need to read the questions 3-4 times, understand what has been asked in the question, then state what is given, then be clear on what is asked, and then proceed solving the problem. Thank you.